Okay, woman starts walking home and walks 6 miles at 40 degrees north of east. So here's north, here's east. So 40 degrees north of east would be something like this. 40 degrees goes here because it's like they're traveling east, but just 40 degrees closer to north. Okay, and it takes them 6 miles. Okay, and then that same person goes 2 miles at 15 degrees east of south. So here's another north here. This is their new position, right? We're doing north, south, east, and west from here. They travel 2 miles, 15 degrees east of south. So here's a southern direction. They're not going perfectly south. They're going 15 degrees east of south. So it looks like something like this. Okay. So 15 degrees east of south. I'm going to draw a dotted line to represent south. That way we know that this is 15 degrees east of south and 2 miles on that heading. And then the last turn they make in their crazy journey home, 5 miles at 30 degrees south of west. So here's where they ended up after those 2 miles. And they went 5 miles, 30 degrees south of west. So this would be west, but they went 30 degrees south of west. And now they're home. That's 5 miles. Okay, now you might be thinking, why didn't they just walk straight home? Maybe there was something stopping them, but this is the quicker way, right? That's the question we're asked, is how far would it have been to just go straight home? And so we got multiple triangles that we could draw here, and I think that might be our only way of getting out of this one. Because what we could do is we could pretend like this is the origin of the x and y axis. Like this point they start at is at 0, 0. And if we could just figure out what this is, x, y, then we could find the distance between those 2 points. I'm trying to think if there's an easier way. That might be the quickest. Okay, so to do that, we want to find each of these points. So let's start with this one up here. It's 6 miles to go directly from 0, 0 up here. But what we want to know is the x and the y coordinates. And that's where we're going to be able to use that 40 degrees in right angle trigonometry. Because the x axis is going this direction, so the x coordinate would be right here. The x coordinate is how far we traveled in this heading. So to figure out what x is, we want what's adjacent to 40, not what's opposite. We want the adjacent divided by the hypotenuse. So cosine of 40 equals the adjacent divided by the hypotenuse. That's why I chose cosine. Sine would help us solve for the y coordinate, which we'll do in a bit. So 40 degrees cosine, and I multiply that by 6. So that's so we'll say 4.6. X is 4.6. And again, I multiplied by 6 because that's the opposite of dividing by 6, right? So the x coordinate here is 4.6. And the y coordinate would be what's opposite of 40 divided by the hypotenuse. So that's sine. Sine of 40 is the opposite divided by the hypotenuse. So in our calculator, we'll figure out what sine of 40 is, and then multiply that by 6. That's 3.85. So 3.86, we'll say. 3.86 for the y coordinate. Okay, so we know the x and the y coordinates are the first place they stopped at. And now we want to know how much change to get over here. Yeah, I think we're just doing the same thing. We just have a new right triangle that we're dealing with, right? So this dotted line was a southern line. This solid line was a western line, so they make a right angle with each other, right? So we have a new right triangle going on. 15 degrees is right up here where my pencil is. And I don't know this side length, but I know the hypotenuse again in my triangle. So it's another x and y problem where x is going to be solved. Actually, this time x is going to be the opposite of 15 degrees. Right here, I'll draw the triangle over here. 15 degrees, this is x, and this is 2. That's this triangle that we're working with in here. So to figure out what the x and the y changes are, x is going to be what's opposite of 15 divided by the hypotenuse. So we want sine. Sine of 15 is the opposite divided by the hypotenuse. So with our calculator, times 2. So x is 0.52. And then y would be cosine, because cosine of 15 is the adjacent divided by the hypotenuse. So 15, oops, hold on a second, 15 cosine our calculator, and then times 2 to get y by itself. Y is going to be 1.93. So we got for this coordinate, this point I should say, it's 0.52. Oh, sorry. Now this is a change in the coordinates. Before we finish out putting up this coordinate, look, if 0, 0 is our origin, we want 4.6 on the x-axis, and then this distance over here is an additional 0.52. So I'm doing 4.6 plus 0.52. So this is 5.12 for an x-coordinate. And then for the y-coordinate, we start up here at 3.86 above the origin, but then going in this direction, we're falling on the y-axis. So this time I want to take 3.86 and subtract it by 1.93. So we're down to, oh, it's the same thing. What's 1.93? Weird coincidence there. Okay, so this point was at 4.6, 3.86. This point's 5.12, 1.93. And now we got another right triangle going on. Because this is our western direction, and then if we were to go straight south, that's the y-coordinate we're wondering about. So we're talking about this triangle. Let me draw it off to the side since it got a little crammed in there. This is 5, we've got our right angle, and we're talking about a 30-degree rotation for that crazy walk home. So we want to know the y and the x changes again. Changes on the x-axis and changes on the y-axis. So using 30 degrees, x is what is adjacent to 30. So we want to do cosine of 30 equals the adjacent divided by the hypotenuse. So 30, cosine your calculator is 0.866, and then times 5 to both sides. That's 4.33 for x. Now remember, that's the change in the x. So when we went in this direction on our walk home, we're going to the left on the x-axis, right? So we start at 5.12. Going to the left means we're backing up. So 5.12, we're subtracting 4.33 from it. So we end up at 0.79 on the x-axis. And on the y-axis, we need to figure out what the y value is here to find out how much further we fell. So y is the opposite in that triangle we drew. So sine of 30 equals the opposite divided by the hypotenuse. You might remember sine of 30 is just 1/2. So to get y by itself, we can multiply 5 to both sides. So y is 2.5. So that's how much we fell though, right? Because to go from this point to this point, we went down on the y-axis. So from 1.93, we're subtracting 2.5 from it. So it's negative 0.57. Okay, and now we have enough information to help us solve for this distance, right? We want to know this distance right here. That was the original question. So you could use something called the distance formula, or you could just use right angle trigonometry and the Pythagorean theorem. Because to go from here to here, we found out that it's 0.79 from the origin on the x-axis, and it's negative 0.57 on the y-axis. So this dotted black line is the hypotenuse, and we can use the Pythagorean theorem. So negative 0.57 squared plus 0.79 squared equals c squared. A squared plus b squared equals c squared. And so 0.57 squared and 0.79 squared. If we add those together, 0.949. And we want to just use a square root to both sides to finish getting c by itself. So it looks like it's 0.97 roughly. Roughly 0.97 is, so a little less than a mile is how much they could have traveled. And we did some rounding, so the problem might have been designed to be exactly 1 mile. But if you went 6 miles this way, 2 miles that way, 5 miles that way, you went a total of 8 plus 5 makes 13 miles. But if you could have found a direct route home, it would have only taken you 1 mile.